In this video, we're going to discuss the domain of a function. So before you start this lesson, just make sure you generally understand what is a function, and then again, you have a comprehension of the x and y values on the coordinate axis. So every function we discuss has some inputs and some outputs. All right, we kind of want to discuss those things in different scenarios. All right, in this video, we're going to discuss the things that are going into the function. These are our inputs, and those are known as the domain. All right, so the domain is the things going into your function. And here's like the formal definition. It's the set of all the function's inputs. All right, and for us, when we're talking about our general algebra stuff, that means it's all the x values, all right, because those are our inputs. All right, so I want to determine the domain of this function. And again, when I'm thinking about domain, I'm focused on just the x values. I didn't mean to cross that out, to highlight it. All right, just the x values. All right, so I want to figure out, where do my x values start? Well, do I have my function hit -5 at all? No. Is it -4 at all? No. And then at -3, my function kind of starts in terms of my x values. All right, and then I hit all these x values. -2 hits my graph, -1 hits my graph, 0, 1 hits my graph, and I get to 2, and I don't hit my graph anymore. So you can kind of see, if I'm thinking in this x direction, I hit all of these values in this shaded region. All right, from -3 up to 1. So my x values is how I'm going to write my domain. My domain is my x values. It to the left is -3, and to the right is 1. X is kind of between -3 and 1. And now we're just going to write an inequality. And all we need to remember or know that's extra is, if you have this open circle, you're going to have a strict inequality. You're not actually touching -3. That's what that little open circle means. That's not a 0. It's an open circle that's representing that. And if you have a closed circle, like this one, that means you actually do hit that value, and that's going to give you the equal sign in your inequality. It's just a small way. Some functions get really close to a value but don't actually hit it, and that's where these open circles happen. If you think about like all the numbers less than 1, you don't actually include 1. All right, and if you do have that dot, that means you actually do hit that value, so you're going to have the equal sign. So my final answer, I don't actually hit -3, so I'm not going to have the equal sign on my inequality, but I do actually hit 1 because of that closed dot, so it's going to look like that. So x is bigger than -3, but doesn't actually equal it, and x is less than or equal to 1 because it actually does. So this is the way to write your domain as an inequality. It's domain, so it's related to x. X is bigger than that kind of left-hand value, and x is smaller than that right-hand value. All right, so determine the domain of this function. And I'm kind of just thinking in this x direction. I start hitting my graph. If I think about the far left of my graph, I start at -4, and I hit all these x values along the way until I stop at 4. So my domain is x is to the right of -4 and to the left of 4. And you can see both of these are closed dots at the end of my graph, so they're both going to have the equal sign like that. So my domain is -4 up to 4. All right, x is between -4 and 4. There's a bunch of different ways you can say that, all right, but that's the final answer I'd like to see. X in the middle, and there's kind of 2 endpoints on the outside. All right, so here's one for you to try on your own. All right, determine the domain of this function, and just remember the difference between this closed dot on the left and that open dot on the right. All right, so I'll show you the answer in 3, 2, 1. All right, here is the answer. So the first thing, the numbers, it starts at -3 because that's kind of like the left-hand side of my graph. It ends at 2. That's the right-hand side of my graph. There's a closed dot with 3, so I have that equal sign. There's an open circle at 2, so I do not have the equal sign at my inequality. So that's the domain of that. All right, and sometimes you're given scenarios. You want to think about what domain would make sense for this scenario, where you're just thinking about possible things that would make sense in a situation. So this isn't like a mathematical thing in the sense, other than we're talking about domain. It's kind of more reasoning and what would make sense in this situation. So if you're talking about like the number of pages in a book, all right, what would be values that make sense for that? All right, the number of pages in a book, the least number of pages that could be in a book, probably 1. You could, I guess, could have a 1-page book. That's definitely the lowest I could go. I don't know what classifies as a book. And then really the upper bound, there's some really long books out there that are thousands of pages. So I guess the upper bound, we could say like it's probably less than like 5,000 pages. All right, that would make sense for a domain. I'm not sure how long the longest book is. All right, but 1 page being the minimum for a book, 5,000 being the maximum for a book makes sense. All right, but you could also put like, maybe you don't consider it a book unless it has 100 pages. And maybe there's a book that's 10,000 pages. So as long as you can kind of reason for why that's your domain, that makes sense. All right, the scores obtained on a test, that is more strict. The lowest score you could ever get on a test would be a 0. And generally the highest score you can get on a test is a 100. So that'd make the most sense. Maybe you can make an argument, oh, my teacher gives extra credit, so I put this as my domain. That's still fine as well, as long as you can reason for why that is true. The amount of money in a bank account. All right, the amount of money in a bank account, you could probably assume 0 is the least amount of money you can have. I think you'd actually have a negative balance if you overdraw. But again, just generally 0 is the least amount you could have. And what's the most money you could have in a bank account? A lot. Most people would probably stop like that amount because that's the amount that's insured by the government. But again, people have a lot of money, so maybe you could put like $1 trillion. No one has more than $1 trillion in a bank account, so that would basically make sense for a range of values. That would make sense for the amount of money in a bank account. Again, these scenarios, you're kind of using some words to help explain why this is the case. Maybe if you were, say, like, smart people would use that amount because that's the amount insured by the government, but for a fact nothing is going to get bigger than that. That also makes sense. All right, just thinking about ranges that make sense for a scenario. All right, so go ahead and practice this. Most importantly, practicing that finding the domain from a graph. That's the most important. And just using kind of your reasoning skills to see what domains would make sense in different scenarios.